and we'll jump right in.
Recording in progress.
Okay, so today's lesson is about feature engineering. And what I'm going to do here is share my screen. And I would like to start with a discussion with everybody first. What in the heck is feature engineering? And where I want to start this is, what do you already know or have heard about this topic already? And then we'll take it from there. If it's absolutely nothing, Ryan, that's why I'm here. We haven't done this lesson yet. That's totally okay. We have used this term a couple of times in class though, right? So from the context and from any further reading that you've done, I want to open it up for a class discussion and ask, what do you already know about this topic already? And with the alternative topic, like, what are you curious about? So we'll do this class discussion style.
So I guess our earliest kind of example from class, when we were talking about the iris data set, we had the link at a column where we calculated the area. That would be an engineered feature. And so it's kind of pulling from another source or looking at our data in a different way to make something that isn't there that could be useful. And so one of the things that I've been thinking about in terms of feature engineering for the Zillow data set, we've told that our best multiple linear regression models, all of our features should be independent of each other. Or in many cases, that's best. Well,
that's a nice to have.
I mean, the first three features we're dealing with for our minimum viable product model are area, number of bedrooms, and number of bathrooms. And clearly, all three of those are very much intertwined with each other. I mean, the more bedrooms you have, you probably have more bathrooms as well. The more rooms, the more area. So I guess an engineered feature, if we like weighted bedrooms and bathrooms and came up with just a weighted room score, that would be an engineered feature. It would be a single feature that kind of gets rid of some of the interdependence between two of the existing ones.
Yeah, that's a great discussion. I hope you don't mind that I took the liberty of naming some of those options in my notes here. Square foot per room, which kind of combines all of those, right? Total number of rooms, square foot per room, and the number of rooms. Because like bedrooms and bathrooms are not totally divorced from each other, right? The number of bathrooms is generally a function of bedrooms. Yeah, that's a great example, Jared. Did you have anything else you wanted to tack onto that? I think that was a real good addition.
That's it.
Cool. Yeah, absolutely. You're using what you know about life already to inform your modeling. And this is one of the reasons why we don't just make kitchen sink models out of everything. It's because usually there's some wrinkle in reality. Like bedrooms and bathrooms are not independent, and they are not independent of square footage either. Great example. Let's see, what else is coming to mind for y'all?
I did a feature in Zillow called Age, where I took the current year. I made it more complicated than it really needed to be, but I calculated the current year and subtracted the year built. And it was super simple and straightforward, but I think it's maybe going to be more valuable than year built.
Yeah. It's certainly easier for a human being to understand too, right? So somebody's not doing mental math in the middle of your presentation. That would be distracting. Yeah. Thank you, Brian. Cool. Anything else coming up? It's totally okay if this is not a big, huge list. We're doing this lesson for the very first time right now.
Would it also be looking at your list of features and trying to decide which one or which combination of features would give you the most accurate model?
Yeah. It could be, absolutely, Stephanie. If we do, say we imagine we do some visuals, right? We do some visuals and stats tests and discover that columns A, and B and C are nonsense. Or or they have no relationship. They're not drivers. Just because something's a column in your data set doesn't mean that it should always be a feature. So if we discover in our exploration that some features are not good drivers of the target, they don't have an established relationship with target, we just don't model on them. We simply don't model on those features, on those columns. So if we wanted to be, I want to make sure I provide some specificity in the language. You've probably heard, I know that I'm very guilty of this. I use features a lot, that word features, where I use the word variables, where I use the word columns. But I want to pick on myself a little bit for y'all's benefit. A feature is a column going into a model. So that means all features are columns, but not all columns are features. And it's real easy to get those mixed up. And it's kind of like argument and parameter when talking about a function. A lot of people use them interchangeably, but so we can split hairs on this, and that y'all benefit from that clarity. Features are what we're training our models on. Just because something's a variable or a column doesn't mean it makes it to a model. Yeah, so we might just drop features from what we feed into our model. That's absolutely feature engineering. Colin, you got something?
So the term attribute has come up. Is that the same as column attribute, or is that feature?
Yes. Yes. I'd say attribute and column interchangeably. Yeah. And also an attribute can be a programming term. So a lot of our terminology is kind of overloaded, but it's okay. Attribute in English just means an attribute of something. So that's okay. Yeah. Green light go. Yeah. 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 You're welcome. This is good stuff. I like the combining features. And if we know that A, B, and C could be used to make a feature called D, and D is a more clear driver of the target than A, B, or C, then that's feature engineering too. Okay. Not bad, not bad. I think this is about what I'm hoping y'all are already tuned into, that you can make your own columns, you can make derived columns, you can drop columns, and PJ has something to add, so go ahead.
Maybe like statistical testing too with the
Actually, we will be doing statistical testing with feature engineering, like, because if you discover something is not a driver of the target, then you don't model on it. So you'll probably just drop it or just never send it. You may leave it in your Explorer to say, hey, there's no relationship here. So you show that there's no relationship, but then it never makes it into the model. Does that speak to your question? Yeah, yeah. Yeah, just because there's something that is not a driver of the target doesn't mean we don't mention it. We mention it in the report. We mention it in the Explorer, but we just don't model on it. Okay, this is awesome. This is awesome. Some more ideas for feature engineering. I want to share this with you. Maybe the number one source of feature engineering is knowing your domain. Because every domain is different. Every business is different. Oh, we don't even different franchises at different businesses work differently, right? Now, McDonald's may have a playbook for everything, but oh, at this store, we did it this way. That kind of stuff happens from time to time, right? But knowing your domain or knowing your specific organization is really the number one way of knowing how to feature engineer. And what we're going to introduce in this lesson is some automated feature engineering. So in case you don't have a great amount of domain experience, or you just need to know what features are most important in what order. And that's what we're going to introduce today. So last call on what we already know about feature engineering before we cover some new material. All right. Okay, cool. Let's jump in. I'll share these notes in Slack after the lesson. All right. The notebook that I'm going to be running here is exactly a copy of the curriculum. So it's nothing different. And our definition here, the top, feature engineering is a process of transforming raw data into features that better represent the underlying problem to predictive models. The goal.
Sorry, Ryan. While we're kind of in the free-for-all questions, because I don't know if this is the right spot for this question, but something I've been pondering, I'll throw out there. So, I mean, we were doing all of our decision trees and stuff like that for our categorical things, and now we're using our multiple regression for continuous variables. Is there a single modeling technique that encompasses both of those, or would that be getting into like ensemble methods where we're like weighting multiple models with categorical and continuous drivers? Like if I wanted to do like has swimming pool, yes, no, as one of my, is there a way to incorporate that into a multiple linear regression model?
Actually, absolutely. Yeah. So our inputs, our features for either, so our target variable in regression is continuous, right? Our target variable in classification is categorical, but we can use numeric features or categorical features for either model. And I'm going to add this onto our notes here. We can transform continuous variables into categorical by making them binaries or bins. This is actually pretty common. We might not want to look at every single age home. We might just break it into old, medium, and new. Right, so like old, medium age, and new homes instead of the age itself. You don't, just because you can doesn't mean that you always should, but we could do this too with house prices. Expensive, medium, low, or 4 options or 5 options. Or like the pools. I think Jared brought up the number of swimming pools. Well, if some mansion has 7 swimming pools, but the model is going to perform better with just a nice binary, then we can convert that into a binary. Absolutely. Jared, did that speak to your question?
It did. So, I mean, basically, if we have just a column of 1 and 0s, that, I mean, we could treat those as if they were continuous and pass them as features to a multiple regression.
No, I see.
That was the question. How do we, if we've got, yes, has swimming pools, yes or no, can we use that in our regression model? And if so, how? That's my question. And that did not address
just
it.
throw it in as a column in your, that your model on. Yeah, same as we were doing with like dependence versus no dependence, is senior citizen or not. Those were all 1s and 0s. So they're binaries. But gosh, like with decision trees, we're looking at those features. A decision tree will actually break down a 0-1 column and make the split point at 0.5, right? But if those values are numeric, it'll make the split point at 1978 or something like that. Did that provide a little clarity, Jared?
Well, I mean, the way we're using categorical variables in the last section that we already used categorical variables on, I'm fine. But like I said, when we're using this regression for continuous variables and we have categorical data in our data set, like specifically with it as we're building a multiple regression model for home values, can we pass it the categorical column and it just treat those as if they were numbers and it work out fine?
Yep, it'll work out fine. Absolutely.
Cool. Thank you.
Yeah. And I'm really glad that you asked about that because it's drilling to the heart of the issue, like how much is different about regression than classification. And really it's the target and the algorithms. The features will remain the same. But we don't have a constraint on our features to only be categories for categorical prediction. It's only what the target is. Same thing with regression. We could do regression only with categorical features, but what defines a regression is the target variable being continuous. So short answer, that's a very long way of saying, Jared, yes. Yes, we can use the features in the same way. Yeah. Cool. That was a great question. I'm really glad that you piped up and asked that one and tacked that on to the end of our discussion here. Because I've seen that confusion before, or not confusion, but I've seen that question before. We don't want to scatter plots with binary columns because it's kind of hard to see, though, right?
Ryan, I have one thing for Jared's questions. Okay, let's ask the business value of that question, right? Suppose I'm a real estate investor, right? How much price I want to give that to that particular house, right?
Yeah.
First of all, that question will be just like, okay, does that house has a swimming pool? If that house has a swimming pool, per square foot, I will give this much to that house. If this house that has no swimming pool, then I'll give this much square foot for that house. That's the maximum price I'll go, right? Now, can't we classify that kind of thing by using on our SQL and classify our data set prior and proceed with the questions?
I think I understand your question. Correct me if I'm incorrect. If say
No,
you're a real estate.
The classification we can do while putting our SQL query, right? While pulling the data, right?
I'm a little lost on how SQL's part of this question. Could you connect that for me?
Yeah, because we are trying to classify over here, right?
When you say classify, I mean, we're working on.
Classify all the houses with a swimming pool and without swimming pool, right?
Oh, okay, yeah. Yeah, that's yeah, it has swimming pool could be a Boolean when we don't, or if we don't want to count swimming pools individually. That's okay, I'm with you.
And now look, we'll categorize the whole, split whole data with swimming pool, without swimming pool, right? We did the part of our classification technically, little bit, right?
That's not classification. That's just making a binary, man.
Okay. Okay, never mind then.
Yeah, I think you might be overcomplicating it, Rajaram. Because has swimming pool is not our target variable, right? Our target variable here is tax value of the property. And because like 2 swimming pools is not twice as valuable as 1 swimming pool necessarily. And I say that with some domain knowledge, having worked in IT and real estate for 3 years, at least in South Texas, swimming pools don't add a lot of resale value. Strangely, unfortunately, given how expensive they are to build in South Texas, right? But yeah, since 2 swimming pools is not twice the cost of 1 swimming pool, at least on the buying side, it is if you want to install one, right? Then we could simplify some things by making a binary here and just simplifying a number into a yes or a presence of a swimming pool or not, making that a binary is not a classification. We could do this as part of our data prep. We could do this as part of our explore it and see if it's valuable. If it's valuable, throw it in your data prep and then drop the number of swimming pools. Or keep it around, model on both, see what's better. But usually swimming pools don't add that much value. Maybe in Southern California where they have 17 swimming pools, but I don't know.
And then, sorry, Roger, I'm glad you brought up sort of like the business use and context and stuff. With our telco, I mean, it was really easy to figure out what the business case and like what the value of having a predictive algorithm for churn is. But I mean, are we just kind of use this to look at undervalued and overvalued homes? Or, I mean, are we trying to use this to figure out what prices we're going to list this as? Like the, it's a
Yeah,
little less explicit how to connect the dots between our model and what our desired use cases of it are.
yeah, I'd say, yeah, if we're investors who want to buy a property and then turn it around, or home buyers who want to find a deal, yeah, looking for undervalued homes. If we're sellers, if we're selling properties, see, I mean, really, it comes down to that age-old question: what's driving the outcome? What's driving the tax value? And in this data set, we don't have the sales price. I want to make clear that everybody's on the same sheet of music. You probably haven't seen sales price. You see predictions, and then there's tax value, but we don't actually have the sales price, right? And that's because sales price is private intellectual property of the multiple listing service. That's why it's not public. So tax value is our driver.
I have a question.
Yeah.
Tax value, property value, is there a difference, or, and if there is, what is that?
Let me pull up our, let's take a look at what we got here.
Because I actually changed the name of that column to property value.
Ah,
So I wanted to make sure that.
yeah, let's take a look at what we have to work with. We have, let's see, tax value, dollar count, tax amount. We don't actually have the sales price, right? Because that's how Zillow makes business. It makes money. They try to give you a prediction, and actually, let's talk business cases. Zillow's reason for being is to try and get people to use their service. Their teaser product is to give you an estimate of your home's value. And that teaser.
Ryan, let me put it this way. Okay, Zillow even doesn't know the sell price, to be honest answer.
No.
Because I'm a realtor myself, right? Zillow even doesn't know the sell price, because whenever being a realtor, I never need to disclose the Zillow or any third party to tell how much I sell my house per. And
Correct.
It's just like you told earlier, it's a intellectual property of what you call MLS services, and they keep it separate.
Doesn't the county tax assessors site,
We
can't you
are
look
not
up what
required to
it's
give. Even they even doesn't know it, because they are by law in Texas. We are not. Nobody is required to tell them how much they bought it or how much they sell it for.
That's a true statement, especially in Texas. A lot of big, huge, multi-million-dollar ranches will not necessarily go through either real estate agents or the multiple listing service. And I've known individuals who have sold multi-million-dollar ranches on paper for $1 for tax reasons, to keep their tax reasons down, to keep their tax value down, right? But you still don't have to disclose that. That's why a lot of counties will try and create their own understanding of value based on features, because the county doesn't want to get hustled that way out of taxes. Yeah, but we do have the tax value, but we don't have the sales price. Okay. In this data set. But the business value here is what's driving the target. What can you do if you understand what's driving the target? Try to beat the other person, right? Whether if you're looking for undervalued properties or undervalued securities or stocks, or if you're looking for overvalued properties if you're on the sell side, right? Maybe we find that the last 2 years swimming pools are hot. Swimming pools are adding more value than years previous. Well, maybe I want to sell now because I've got a swimming pool. I don't have a swimming pool. Right.
I mean, with our output, there are homes that are, I mean, disproportionately overvalued for tax purposes, and of course the mechanisms for like appeal to get that reduced. And so I mean, thinking about or driver and what we're optimizing on, if we're trying to find the drivers not of sale price or value, but of tax value, we might just inadvertently get ourselves into a situation where we're being overtaxed disproportionate to the actual value of our home.
Mhm. Yep. Pretty interesting stuff, right? Every domain gets really, really interesting the further in you go. Even if you're doing analysis on frozen pizzas for HEB, what is that connected to? What's driving the sales in those frozen pizzas, right? Number of frozen pizzas could be your target regression variable, right? But your inputs could be what time of day are people shopping? Are they shopping for a family? Are they single? What other things are they buying? Is somebody just stopping in, getting a frozen pizza and that's it? Do they come every Friday to get a frozen pizza? There's all kinds of stuff. Even if it's just one little thing, one little target you're looking for, there's this crazy story everywhere and that we can unravel, right? Cool discussion. Yeah, cool discussion. So did we leave any stones unturned there before pressing forward? Yeah, we can also use our domain knowledge to weight things. If we know in our domain that something's important, we can weight it more heavily. All right, so we're constructing new features, dropping features, penalizing features, possibly. Some of our methods, this list of methods is going to be larger than we have time to get into. We're going to introduce 2 methods in this lesson. The first method is constructing new features. So using your domain knowledge. That's like if you have height and you have width, make area, right? And that's a very simple example, but in the exercises for this module, you'll see that we'll take that tips data set and get tip per person or price per person. We could also use statistical tests to determine each feature's usefulness in predicting the target variable. And y'all, we're gonna do this, we could do this manually. Y'all already have the tools, but we're gonna be doing this in an automated way in this lesson and introducing a function called select k-best. So that's one thing we're gonna cover today. All right. Another tool that we can use to determine the importance of features is something called recursive feature elimination. And this is amazing stuff. Recursive feature elimination is actually using a model. So using a regression model, if you're doing regressions, using a classification model, if you're doing classification, to model on all your features, then model on all but one of your features, and it models on every little permutation. Okay, that's really cool. We'll be covering recursive feature elimination too. Some other tools that you may hear about or see in literature are something called backward elimination and forward elimination, and other tools such as principal component analysis and regularization. Those 5 different tools are way too much for us to get into today. They are in the appendix if you're like, wow, I'm super hungry for more feature engineering, but we're going to cover 2 things. We've already been talking about building your own features, basically not the entire course, but at least while we've been working on projects. The 2 things we're going to introduce, select k-best, which is statistical in nature, and recursive feature elimination, which is modeling in nature. Okay. And with so many things in this whole wonderful field of data science, it depends, is always your answer. What does it depend on? We'll talk about that a little bit. So I'm going to get into the code here and show you what we're working with. This lesson is going to be pretty short, and I think y'all will find these exercises kind of plug and play. If you copy the code, make it work for your data set, and experiment with some of the values, you'll get a lot out of this. But this is not going to be like a 2-hour lesson or anything like that. It's going to be real short. So here's what I'm using. I'm going to pull in pandas, and I've got a wrangle script that does my wrangling as well as my train test validate split, as well as scaling my numeric variables. Okay. So now I have, we'll show you X-train. Just so you know, have an idea of what we're looking at. X-train explore.head. Okay. So in this, we've set up our independent variables and our target. I think the target is the grade in this one. And this has what school people are going to, gender, age, family size. It's got a bunch of nans in here too, left over, unfortunately. What matters here is not the data set. What matters is what are we going to do to check, to figure out which of these features are important, okay? So I'm going to introduce you to our new friend. It's called select K-best. And K-best is not a Korean pop star, okay?
Are you sure?
I could be wrong. I don't know. Brent knows a lot more about that area than I do.
Sounds like one.
Yeah, but so K is it's a variable. And it's a variable that is the number of features we want to get the best of. So if you have 10 features in your model, the highest your number of features in K-best could be is 10, and it'll put them in order for you. But usually we want less features than every single column in our variable, every single column in our data set already, okay? So here's how K-best is going to work. K-best is going to use statistical tests. So it's all stats in nature to compare each X at every variable from X with Y and figure out which of our independent variables has the strongest relationship with our target, okay? So if we were, you can totally use K-best on classification. In that case, you feed it a chi-squared test. Here, we're going to use what's called an F regression, an F test. In your mind's eye, it's not the same thing as a t-test. I don't want the stats police to come after us, but basically think of it like a t-test. It's just a stats test, okay? And it's all under the hood, so you don't have to do any stats. You don't have to check p-values. You don't have to set your alpha or anything like that. K-best is going to do all that for you, okay? So with any K-best is going to come from sklearn, and with all of our sklearn tools, we have that three-step process. Make the thing, like make an empty model, fit the thing, use the thing. That's the sklearn three-step. So the first thing we're going to do is initialize an F selector object. This is really like a copy paste thing, right? And the defaults are pretty good. The only thing that we have to set is K, the number K. And the whole discussion of how to find what a good number for K is an ongoing and unsolved discussion, because there's not one answer, because every single data set is different, every single business is different, every problem is different, right? So I don't have a use 5 answer for you, right? It's more complex than that. But my attitude is your K will always be less than or equal to your total number of features. But if you're looking for your top 3 features, set your K to 3. Okay. So step 1, you set you make an empty F selector object off of the F regression. If you were using if we were doing classification, we would use a chi-squared object from sklearn instead of the F regression. Then notice that we're fitting. And when, I want to ask y'all a question. When have we fit things with sklearn before?
On models.
On models. Any other time we've fit things on sklearn? Scaling. Yeah, scaling as well. So modeling and scaling all have the same process. Step 1, you make the sklearn object. Step 2, you fit the sklearn object. What do you fit it on? Your training data, right? Not your validate, not your test, but your train data. And then we use the thing. So step 3 is once we get this, that F selector, and like underneath the hood, consider that this is running, this select K-best is running statistical tests for every feature with the target for you. So you don't have to do that. this get support function is going to give us back a true or a false if that feature was useful or not. Okay. So that feature mask ends up being a Boolean array. Yes, this feature was useful. No, this other feature, no, this other variable was not useful, etc. And you'll see here, this isn't some crazy bit of pandas. What we're saying is, hey, xtrain scaled, use iloc to only give me back the features that are important. And then grab the column names and turn them into a list. So let's take a look at that. On this specific data set with, this is certainly more than 8 columns on here, right? But we are setting K to 8 and check out what we get. We get in order the feature importance, the 8 most important features of this model. If we change K to 3 and rerun it, we get the 3 most important features of that model. So I see here G2, G1, I think those are like those are test scores. And this one, this is like a standardized test data set. And then number of failures. Each time we change K, we're looking at, right? So we saw G2, G1 failures and Medu. I have not read the data dictionary for this data set, but kind of doesn't matter. I mean, it always matters to read your data dictionary. But in this place, we're getting mathematically what's most important from a statistical point of view, select K best. That's all it's doing. Yeah, I see a question from Lori. Go ahead, Lori.
So I think you said it returns an order, right?
Mhm.
I feel like before it didn't have the Medu, and now that one is at the beginning.
Yeah.
Did I miss something?
No, I don't think you missed anything at all. Let's try this experimentally. I'm going to set K to 1, and let's get the single most important feature. That's G2. When I set K to 2, it's G2, then G1. And the conclusion that I'm coming to experimentally here is that these are ranked from right to left. At least with this, with select K best. Because that G2, no matter how many Ks I set, is still king of the hill right there. It's just not in the numeric order of the indices. So yeah, you're not seeing something crazy, Lori. It doesn't match my expectation either. I would expect left to right. If it makes you feel any better, the recursive feature elimination will actually put a numerical ranking for us. I'm going to check the chat here. Okay, good. Yeah, that is a good question. Yeah, so with the feature importance, we're going from right to left. I don't know why. I'm not an sklearn developer. But it's tricky. Once you build a library like sklearn, as soon as people start relying on it, you can't change it or you break stuff. Right? Or if you do change it, you break stuff and then people get grumpy about it. Cool. So that's not a lot of code at all. And the only thing that we would do different here, if we were not doing a regression, doing a continuous target, if we needed to do a categorical target, inside of the import, we would import a chi-squared. Inside of the select k-best, we'd provide that chi-squared object there. So it's not a lot of code. Under the hood, it's a lot of code. I guarantee you, this is thousands of lines of code in sklearn. But it runs real quick. And the biggest thing to remember with k-best, we are getting statistically important features, which is not going to be the same thing we get from recursive feature elimination. So I want to make sure we're clear on select k-best before we go into recursive feature elimination. So we're open for questions.
Hey, Ryan, if we were doing the chi-square one, is that the same chi-square that we used in for the modeling?
It is. Do you mean back in the stats?
Yeah, like I see this F regression. I don't remember. Well, I guess this is the first time we're doing regression, but is it the same chi-squared, or is there like something else that's used specifically for the select k-best?
Yeah, actually, it is the same chi-squared that we learned in stats, but we don't use the SciPy stats library. We use the chi-squared that's defined by sklearn. That's actually the only difference. So just so I'm not waving my hands and saying, oh, imagine this, I'm going to copy my cell, and that name of that function was chi2. So if we had a categorical target, we would do chi2 here and then chi2 there. That's it. That's the only difference in using select k-best on a categorical target versus a continuous. And I realized that yes, chi-squared is not, our definition of chi-squared is only taking in categorical x's and y's, but sklearn has some magic underneath the hood for us, so we don't have to worry about it. It's just going to run it. And that's it. That's all you got to change. The only difference though, and I'm glad that you asked that, Lori, the only difference is, yes, it's mathematically chi-squared, but we're taking the test not from SciPy library, but from sklearn's library on this one.
That's the target variable and it's categorical.
Categorical, if you're going to do a classification. Yep.
Another question.
Yeah.
So what if we want like a combination of features, categorical and continuous?
These choices, great question. These choices are about your target, not your features. So this will come up. Let's say if you have a classification target for your capstone, let's talk on how to make this work at that point. But it's really just like 2 lines of code different, actually just 2 variables different. Yeah. Cool. So the big thing to remember here is that select k-best. I know that it says regression here, but it's actually it's a statistical test underneath the hood. It has much more in common with a t-test or a correlation test. The difference between k-best and our new friend, we're introducing 2 new friends. Our second new friend is recursive feature elimination. And anytime you're at a party full of nerds and you say the word recursive, your street cred goes up, right? But here's the difference. A recursive feature elimination tool, instead of using statistical tools, it's going to actually model on all the features, build a model, evaluate it, and then start reducing some features. Build a model, evaluate, then reduce the number of features, okay? So the difference is, like computationally, why would you care to use one versus the other? If one's statistical, one's model-based, the k-best is going to be much less computationally intensive because you're not building dozens or hundreds of models. You're running dozens of hundreds of stats tests, but building models and evaluating them requires a little bit more processing. On our laptops, on data sets of this size, it's not that big deal. Maybe on Zillow being about 2 million data points, it'll add a minute or 2. But if we're talking like terabytes and terabytes of data, I would stick to the stats instead of the model-based. Okay, but the cool part about the model-based, let's talk about how this works. RFE creates a model with every feature. That's that kitchen sink model. I've talked about that before, where you just model on everything. It's not always great, but it gives you something. So RFE models on everything, evaluates the performance metrics, okay, finds the weakest feature, and then removes that weakest feature. So every time RFE makes a model, it figures out the weights of those features, what's important, and then drops the least impactful driver, okay? Then it creates a new model with the remaining features. Because if we modeled on 5 features, found a weak driver, then we model on 4 features. Once we model on those 4 features, we're modeling on less things, but because we dropped that 5th feature, we're modeling on the interplay of those 4 things, not including the noise of the 5th. So we get some noise reduction in here, okay? But that process and the recursion here is that we keep doing this process over and over, okay? With RFE, we have to tell RFE what ML algorithm we're going to use, right? So here, once we look at the code, we're going to send a linear regression into the RFE so that it makes a straight line linear regression for everything. If, for example, though, you charted your X and your Y and you didn't have a straight line, you had a curvy line, polynomial town. Polynomial is a fancy word for curvy line, right? So if you wanted a polynomial model to check recursively your best features, instead of linear regression, you do a polynomial regression. So RFE could take other models, not just linear, because it's modeling on everything. So this is really cool. Our steps here, step one, initialize our machine learning algorithm. So we make a blank model. And RFE is going to take care of the training and evaluation and everything. In our case here, we're doing simple straight line linear regression. If you wanted to do ridge regression or lasso or other fancy regressions, you could. If you wanted to do classification regression models, you could. We're in regression, so we're doing regression models, right? Then we initialize that RFE object. So step one, it's empty. Step two, we make the RFE object. So how did we do that? From sklearn, feature selection, import RFE. Then we say RFE, that's a constructor function. It takes in the variable that holds the model. And that second variable right here is kind of like K. It's the number of features you want to end up with. Ryan, what's the best number for K? It depends. And it's not the same for every data set. So I can't give you 2 or 5 or 7, okay? But I'd say less is more. To get an MVP model out the door, choose your top 3 features, right? Just get it out the door, and then improve from there. You'll notice once we build that RFE object, 3 steps: make the thing, fit the thing, use the thing. So we made the RFE object, then we fit the RFE object. In this case, I'm fitting it on scaled data, right? Generally good to use scaled data for your models. Right? Makes your models faster at the very least. At the very least, it makes them faster. And then what we can get from that fit RFE model is a feature mask. Okay, and that feature mask, check this out. That feature mask is the list of features of their importance. Now, RFE has a nice little tool that I don't think exists on the KBest. If we get the ranking of everything here, check this out. So once we have the RFE model trained, if you ever see a property on the end of an sklearn object with an underscore, the underscore means this is something that we get from the trained model, had to be trained first. Okay, so we're going to get the ranking of all the features. Then we get our names of those columns, and we'll make a data frame out of the variable name and the rank. And check this out. If we sort our values in order, and you could use this code on your project, right? Rank is importance, and then var is the variable name here. So G1 and G2 are both rank 1. They're both very important. The third most important, or the second most important rank, according to modeling based, is number of absences. And you'll notice that both the RFE and the KBest they agree on the G1 and the G2, right? But they're not agreeing on absences. We see that the statistical approach was pulling features and then medu, whatever medu is. But we have G1, G2 absences and age, and medu is way down here, okay? So you're gonna get a lot of overlap between feature engineering that's statistical that tells you what's important and feature engineering that's model-based that tells you what's important. When do you use one of these versus the other? The easiest thing to say is when you have a smaller data set, I'd use the statistical. If it's like terabytes and terabytes and terabytes and you're paying by the hour on AWS, I'd use stats-based, right? If you're just running something on your laptop overnight, run them both and see where they converge. Right. And I'd probably use a combination of the top features for both, especially where they converge, right? If both the stats feature engineering and the model-based feature engineering agree that G1 and G2 are good features, absolutely going to use those, right? And that is recursive feature elimination. Again, if we were doing a different kind of model than linear regression, the only thing that changes is the type of model we send in to RFE, which is good stuff. Okay. If you are interested in even more algorithmic solutions for feature engineering, the topics are principal component analysis, regularization, forward selection, backward elimination. We've got something in the appendix for that. I think teaching you 2 things right now is plenty, though, right? One that's stats-based, one that's model-based. You'll see that there's 2 components to this curriculum. There's a short version and a long version. The long version is all the same code. The only thing that's different is the number of Ks. And there's a little bit more explanation written down. So I promised y'all this would be a short lesson. Even the longer version, same deal. Import feature selection, select K-best, F regression, if you have a numeric target, create your K-best object, fit it, use it. Right? And then what we're really after is getting what features are most important in which order. And what's nice about RFE, it tells you the order as long as you use the ranking property or the ranking parameter there. And then you can take that to the bank right here. Just grab your first 5 features and you've got features to make a model on. It's really quite cool. So like I said, the longer version is the same thing as the short version. It's just got a little bit more text and different K values. There's nothing terribly different. And then, yeah. So really the summary is use one or both of these tools. You may find that if you use recursive feature elimination, the model-based approach to select your features, you might run the risk of an overfit model. If you end up having an overfit model based on features you selected with RFE, my advice would be to fall back to select K-best. That's just a nudge. That's not a best practice. That's not in the literature, but it's thinking about that logically. If we've overfit something model-based, then we might as well look at something that's more statistical-based. Cool. Yeah, Kyle, go ahead.
So do we do this before we start exploring? When do we do this? Yeah, the pipeline.
I would do this. Feature engineering can happen in Explore. It can also happen in modeling. Like after you built your first model, you might want to run these and see if you can build a better model. So it's totally legit to say feature engineering can happen in Prepare because you combine features. It can happen in Explore because you discover features or make new ones there, or it can happen in modeling where once you make a model, you might want to make a better model. It's not linear. Yeah, it's not real linear.
Just like work-wise, if I'm trying to get a MVP out the door and I have this whole data set, I'll just run this, get my best 5, and then start working from there. Is that how it would work?
I would strongly encourage you to, I know we press a gas pedal for the MVP. The challenge with these is that there's no visuals, right? So we don't really have an idea of the impact. And there's nothing that we can take away to our stakeholders from recursive feature elimination, not other than just these are the important features, but we can't talk about the interplay, right? Or proportions.
Well, I'm still thinking still do your visuals better.
Oh, okay.
You got your columns down.
Oh, yeah.
And then you can just work with those.
Yeah, absolutely. Yeah, there's not a if this, then that on when to use feature engineering, because it can pop up and Prepare. when you just notice, oh, length times width, I'll make area. Or it can pop up in Explore when you discover some features are garbage, you just drop them. Or you may learn more about the data in Explore, right? And you might explore the domain and learn the domain a little bit more and decide, oh yeah, maybe I will do has pool instead of number of pools. And then, yeah, also feature engineering can take place in the modeling, because you might make your first model, your second model, and then want to try and improve it. Yeah, good question. Good question, Tom. I see your hand raised for a question, Lori. Go ahead.
Yeah, I guess I'm a little confused about for the RFE one, you had put in, I think, a 2 for the number.
Yep.
And we got a ranking of all of them. What does the 2 exactly do? Or was that something completely separate than?
No. So right here, we're saying, give me the 2 most important with that argument into RFE. And when we get those features back, RFEs, see this support property right here?
Mhm.
That's telling us which two are the most important. But that same object, that same RFE trained object has a memory of every feature, because RFE models on every feature to begin with.
Okay, because my thinking was, wouldn't you do that first? But you can't, right? Because you have to train it first
Correct.
in order
Correct.
to do that.
Yeah, and let's see, sklearn RFE, it might have a default. Yeah, it doesn't have a default, so it needs some number there. The default is none, which is not very helpful. The reason it's none is because RFE doesn't know how many columns you have. So it couldn't set 3 if you only had 2 columns, you'd get an error. But I like what you're asking about, because this RFE object, once you train it, I'll show you what I mean. That RFE object, RFE ranking underscore. Ranking is different than the support. Ranking gives us an array of the rankings, and what this is using in that data frame is to put all of those in order for us. But yeah, we really did need some number right here in the first piece, because you might want to change your mind, right? You might want to say, what if I want the 3 best or the 4 best? But the RFE object just needs some number here so that we can produce the output of everything.
So I'm curious, is the support one, is that that's what you're trying to get from the beginning, or is that just an extra feature that kind of shows you?
It's the 2 most important features. The support is. Think of it as a side benefit. Here's the thing, you have to provide some number to RFE to say, give me the 2 most or the 3 or the 5 most important features. But as a side benefit, once you've trained the RFE, it can tell you the ranking of every feature.
Okay. And with if you don't need that as a side benefit, I guess
Then don't use it.
what's the other output?
Just if you say, give me the 2 most important features, you get the 2 most important features.
Oh, okay, I see.
Yeah, but generally people are pretty curious. And if you've set up your RFE to tell you the 2 most important, you might want to know the 3 or the 4 most important, or the least important. Look at that, study time doesn't seem to have an impact on the grade here. That's surprising.
So quick question, if you
Yeah.
left your number as none, does it just give you the ranking of the whole list?
Let's try. Well, if we leave it as none, the features, it puts them in order from right to left. And then the same ranking gives us the ranking. But this is kind of weird because it ranks all of these as 1s. And that's kind of janky. Yeah. So I would avoid nones in there. I'd provide some number. Yeah. definitely less than the number of columns you have. Like if I put in number that more columns than we have, it's gonna blow up. Oh, it didn't blow up. It just tried. That's good to know. But yeah, 3 most important, 2 most important. And then once you've trained that RFE, because the RFE is, think of it as a model of models, or an object that has a memory of all the models that it's worked with before. Yeah, Brent.
So if you set that to 4, is it the first 4 gonna be ranked as 1?
There we go. Look at that. Look at that hypothesis formation. Pattern matching and hypothesis formation. Yep.
If you put 4,000, will they all be ranked as 1?
Every column.
I leave that to it as an exercise for the reader.
Is it common to see where, since it's when you split, it's randomly splitting, that occasionally one feature might beat another one depending on how it's split?
Could. Yeah.
Worth following up on, or probably pretty random stuff?
I don't want to discourage you, but I don't think that there's gold in those hills. Yeah. Yeah, because if the randomness is generating a signal that's not really the signal, you can change your random seed. Yeah, and make sure that it's not just, that you're not chasing a ghost. Yeah. Like they do over at the Alamo. This room's very spooky. Yeah. Cool. You can go a lot deeper if you want, but for these exercises, they're really, really, really straightforward. Pretty plug and play with this code here. For the exercises, we'll be working with a tips data set. We'll do some manual feature creation. If we have tips and we have the bill, we can get the tip percentage. Because that's what I would want to know if I worked at that restaurant. What's the actual tip percentage? If the tip's $5, but the bill was 100, like, that's not great. And then we calculate price per person. There's some thought points in here. Then we'll crank out some K-best, some RFE. And then you'll write a couple of, for tips, and then you'll write a couple of reusable functions. Guess what you're gonna reuse these functions on? Zillow, right? Make a couple of your own functions here. And then at the very end, you'll work with the Swiss data set with your target of fertility on the Swiss data set. Cool. Cool. As useful as these new tools are, these automatic feature engineering tools are, I do want to leave y'all with the mindset that your best features or your best models are going to come from better input data, not necessarily from magic algorithms, right? Knowing your domain, getting to know the importance of features in your domain. That may mean on the job, taking somebody out from accounting to coffee to talk shop and figure out what's important to them, what they already know. Because spreadsheets don't tell you what they actually know. They just tell you what they hold. Right? Human beings usually have much more answers for you. So if you're working on a project for the accounting department, take somebody from accounting to coffee out and talk shop. That's a good way to get domain experiences, to talk to somebody who has to live and breathe it. Say, what are your pain points? What are you trying to do? Do you know why they have me working on this? Why is this important? Why is this important to you? You might be really surprised by what you learn. Oh yeah, we've been recording those 3 columns for the last 10 years, but nobody uses them. And then that'll save you a whole bunch of time fussing with them. Right? Or maybe they've been recording those columns and you discover that there's a really strong relationship with the target, right? You'd be surprised what you can learn about the domain and the enterprise that's not in an sklearn function. Hint, hint, wink, wink, nudge, nudge on the workplace. Right? Get to know the problem. All right.